Morning, my dear students. This is your science friend Srinivas. Today, we are tinkering my washing machine. It worked well for almost 8 years. This is LG 6.2 kg model top loading. So suddenly what happened? 2 days ago, it stopped, in between the process. Most interestingly, there are many functions here. You see, there are many functions. I can show you. See, there are so many functions. So, there is a microprocessor inside, and because of which there are many programs designed by the company manufacturers. So we can select all that program modes for various purposes. And we can, but this electronic programming module control inside, this is working well, good. So we have tested one by one. So what could be the problem? We have seen the main drum and we have seen the motors and everything. So every time I switch it on, exactly at half the process, so it is stopping and giving me an error 0E. So I just figured it out through the user manual and all, and finally I came to know the 0E is for drain out issues. So, but however, the drain out issues in the beginning process, that's working nice, that it is draining whatever water is there in the drum and all. But in between, why that problem is coming in between? So I started understanding, because I'm a thinker, I always wanted to check what is the possible, probable issues with the designs. So this is well designed, no doubt. But the thing is, I have checked up everything properly. And here is one interesting point. So this is giving level sense to this pressure switch. See how they have integrated the physical quantities into electrical signals and then electronic processes. So I just wanted to make my few mentees. So one is here, Puneet. So he is a 4th grader, and his brother is Gautam. He is a 2nd grader. So whenever there is a holiday, they'll come to me and they'll try to ask me so many questions. So I'll always give them an ideas. And so as you all know that, reduction, reuse, recycle. Let us do service instead of throwing everything. Okay, just use and throw and then order a new one. I don't think it's a good decision for India, because India, we are the more people, maximum people. We are the highly populated people, and everyone in India using a lot of machines at every single home, like washing machines and AC machines, refrigerators, and many. But the problem in India is, these days, the mindset of the people in India has grown to such an extent, if anything going wrong, and immediately throwing off and going for new. So I think this attitude must be reversed. Earlier before, almost 20 years ago or 30 years in between, mid-90s, up until 2000. People used to go for service, but unfortunately, these days, many people, they think that going for service is a big waste. If that is the idea of the people, then what shall we do with this waste material, if at all, defunct material? A lot of waste. It is going to be huge waste, the metal and the plastics, the designs, the motors. For a small, simple things, if everybody is throwing everything out, and definitely it is not sustainable. Okay, so we need to, one of my Guruji, Professor Chatan Singh Solanki from IIT Bombay, inspired me a lot with, how we can reuse for sustainability. And also he mentioned clearly many times, I can afford being a professor at IIT Bombay, but my mother planet, my mother earth cannot afford. That is true. We all have become a big consumers. And simply, using all the resources provided by Mother Planet, Mother Earth. But definitely, this is not sustainable at this point of time. People are using for every single thing. My professor says even making a toothbrush, you require energy. For everything, whatever you make, you require energy. So, if you are wasting some of the things, then definitely everything just use and throw, then a lot of energy is getting wasted. Not only production, not only for designs. In fact, even including the transport of the product, also consuming a lot of energy. This is what my Professor Chatan Singh Solanki has given me many times. So with that inspiration, as you know that during my engineering times, or even while I'm there in a school, high school, I used to open a lot of things. Whatever comes in front of me, I open it up and see how the things are functioning. That's where I understood science and the technologies, and to convert all the sciences into technologies, I wanted to be a practical engineer, which is what I really enjoyed all these 35, 40 years also. But now, these days, I'm becoming older. I have a question in my mind, the kind of attitude, the kind of, hands-on skills are missing. That's why I'm trying to invite some students, and whenever something happening in front of me, so let us open and explore and tinker them. If we can make them work back on, that's nothing like it. If not, okay, at least open the parts and let us understand what every individual part doing. Like here, one pressure switch, I'm trying to work on it now. So these children, like one is Gautam, the second grader, and this Puneet, the fourth grader, are lucky enough to see everything in front of me, how it works, how it completes its cycles, so that it's washing my clothes every time. Okay, so let's explore it and then open it and make it. So after making it rework, then I'll show you that whatever I do about it. Okay, so I'll start from this particular drain out. The sense point to give a pressure here. See, that has come here, and from there it has to give a signal at what water level through the pressure. Okay, so I can check it up by blowing a water into that. I can see the connectivity, whether the connectors are properly or not, and then if at all everything looks like fine, and probably the problem is the sensor, so I'll replace the sensor and I'll make sure my washing machine works on very good. I can show you while it's washing. Nothing is rocket science, man. Everything is designed by us. So let us open it and gain confidence and tinker them and save India by reusing the material. Okay, so why import when you can export? Make in India, made in India, skill India, at school India. Jai Bharat, Jai Hind, Jai Jawan, Jai Kisan. Happy tinkering, keep innovating. Signing off, your science friend Srinivas from scientificstudents.com.
Bye.
Happy?
Happy, sir.
My dear students, so as I have explained about restoring my LG 6.2 kg washing machine, so we found a culprit. This is the sensor, pressure sensor. So there are electrical connections. So we found a lot of dust onto that electrical connections. So we have cleaned them very nicely now, so that the signal will go properly to the microprocessor, the unit, control unit. And you see here, this particular, this is a place the pressure goes inside from the water pipe. The water pipe other side is connected to the main drum. So whatever water is there in the main drum, so because of that, the water level goes more and more into this pipe, plastic flexible pipe, which is connecting here. So the water may not go into the pressure switch, because the water column is raising slow by slow. So there is a pressure increased inside this tube, and because of which the pressure goes more and more in the pressure sensor. Okay, that's where the output signal changes according to. That's where the programming has been done in the process unit, control unit. So we'll replace this, and later I'll also try why it went wrong inside the sensor also. That also I will try and make you understand once I open it up. At this point of time, I have no clue why it is not working. So as today is Sunday, I don't think I'll get this component in my local markets. So tomorrow I'll bring a new one and replace it and make sure my machine works back on from tomorrow onwards. And then I'll try to attend what went wrong into this pressure switch inside, because not only simply replacing and throwing it up, including this sensor, we need to understand what went wrong in this sensor also. If we can restore the sensor, then definitely nothing like it. We can understand what is the process happening inside, and also you all can, as today is Sunday, I'm not getting the component locally because shops are closed. So if I know the process how to make this work, that's it. You all can make it work without replacing the new sensor also. If it is not possible other way around, other than throwing it out, there is no other way. But at least we'll understand what's going on inside, how the pressure switch works inside, all these things we need to explore ourselves. Okay, I hope we understood everything well, and let me once resolder these joints also, so that if there is any loose connection inside, that will also take place. Let's see, let's explore, let's tinker everything. Okay, let's tinker. Happy tinkering, keep innovating. Bye bye. Hello my dear students. So this is a place from where we have taken out our pressure switch. Okay, and next to that there is a metal box in which here is a line filter. This is called line filter. So what this does, whenever there is an excess current pulled by the machine, or whenever there is a high voltage applied to the machine, the fuse will go bad. And also there are LC filters are there. LC filters are to improve the power factor, as well to help machine to get pure AC power inside the motherboard, mother circuit board and all. So it's basically altogether it's a line filter, okay, with the facility of fuse inside. Okay, so I'm going to fix them back. Okay, as there is no complaint into this area. The problem is with the pressure switch. We will be replacing the pressure switch very soon. My dear students, this is a water intake valve, a kind of solenoid also. So whenever this motherboard gives power to this particular coil, so this will become an electromagnet and pull that particular lever inside this valve, and that's where whatever input water you have opened, that will go into the water drum here. Okay, you understand? So what is the details on this coil? You can see, you see GND ground, and you see you can read them at what voltage it works. Okay, see it is working on DC 12 volts. See, that means whenever motherboard gives DC 12 volts, that's it. It will be electromagnetized, and then it will pull the lever. Okay, see, this is the blue one. The blue one is a electromagnet. It's a kind of solenoid. Okay, and the threading ones are basically water input, and then whenever the valve is on, the water is allowed to go inside from the other threading. That is nothing but our main drum. Okay, you understood very clearly? Nice.